Hey, good people, welcome back. I hope that all is well. In this video, we're going to look at how to solve logarithmic equations. So we will use the property of logarithms in some of these problems to express our logarithms in exponential equations or an exponential form. And then we will solve for the variable. Now keep in mind your domain of whatever the logarithmic function is, your solution must be in the domain of the logarithmic function or equation. All right, so here we want to solve the following logarithmic equation. Be sure to reject any value of x that is not in the domain of the original logarithmic expression. Give the exact answer. All right, so since I just have log base 2 of x, I know that my domain for those logarithms is simply x has to be greater than 0, has to be positive. So when I find my solution, I just need to make sure that it's greater than 0. So I'm going to rewrite this in the exponential form. So remember, the base of 2 remains the base. The 3 comes over, and the x, 3 and the x basically swap sides there. The 3 becomes your exponent. You're saying 2 to the power of 3 equals x. So you know 2 to the third is 8, so we get x is equal to 8. Now, in most software programs, you would just type the number in the solution, the value of 8 in for the solution. All right, so let's look at this next problem here. We have log base 3 of x plus 7 equals 4. So again, we want to rewrite this in exponential form. So 3, base 3 to the power of 4 equals x plus 7. So I'm just going to flip-flop sides there. So 3 to the power of 4, 3 to the fourth power, 3 times 3 times 3 times 3 is 81. And then subtract 7 from each side. All right, so again, let's look at our domain. This time we have x plus 7 in the parentheses. And remember, that has to be greater than 0 for our domain. So our domain here is x plus 7 must be greater than 0. If I solve that inequality, that just tells me that x must be greater than negative 7. So anything bigger than negative 7 is okay as a solution for this equation. And we got x equals 74, so we are good. All right, so let's take a look at another example. So in this problem, we have 6 times the natural log of 5x equals 12. This is a little bit different from what we had because in the last problems we had log base 3 or log base whatever. And this one we have the natural log. Let's start off by isolating the natural log of 5x. So since I have 6 times the natural log, I want to isolate that by dividing by 6. So now I have the natural log of 5x equals 2. Now I need to get that x away from the natural log. So I'm going to introduce the base of e. And the reason I do that is because the e and the natural log, they are inverses of each other. Therefore, e to the natural log of 5x is simply 5x. Okay, so now I end up with 5 times x equals e to the power of 2. All right, so again, keep in mind we are trying to solve for x. So to undo 5 times x, I would divide both sides by 5. So my exact solution would be e to the second power divided by 5. My approximation, if I need one, would be about 1.48. And again, you would calculate that in your calculator. So the exact solution is x equals, or just e to the second power divided by 5, and the approximated value is about 1.48. Now let's make sure that that value is in our domain. So we have the natural log of 5x. Therefore, my domain says that 5 times x must be greater than 0. And if I divide both sides by 5, that just says that x must be greater than 0, which my solution is, so the solution is valid. Okay. All right, in this problem, we want to solve the logarithmic equation. Make sure that our answer is in the domain, give an exact answer, and a decimal approximation, rounded to 2 decimal places. So we have the natural log of the square root of x plus 2 equals 2. So when I'm dealing with these, I like to go ahead and change those radicals to exponential notation. So since it's the square root, that would raise that to the 1/2 power. Now, I have natural log of x plus 2 raised to the 1/2 power equals 2. Now keep in mind your properties and your rules for your logarithms. I can use the power rule here to pull the exponent down in front of the natural log. Okay, now I want to remove the 1/2 times the natural log, and I can do that by multiplying times the reciprocal of 1/2. Multiply the both sides, or multiply both sides by the reciprocal of 1/2. The reciprocal of 1/2 is simply 2. So 2 times 1/2 is 1. That's why we multiply by the reciprocal. 2 times 2 is 4. Okay, so I'm at natural log of x plus 2 equals 4, and I need to get that x away or out from under that natural log. So here's where we introduce the base of e. Okay, so I have e to the power of natural log of x plus 2 equals e to the 4th. Now what that does for me is allows me to use the inverse property, because e and the natural log are inverses of each other. And that just gives me x plus 2 on the left hand side. And then the final step to the exact answer is to subtract 2 from both sides. So the solution is x equals e to the 4th minus 2. The decimal approximation for that is about 52.60. Now let's make sure that that answer is in our domain. Let's go back and look there at what we were taking the logarithm of. So our domain must be x plus 2 is greater than 0. So x must be greater than negative 2, which it is. So that's a valid solution. All right, we're going to look at a couple more examples. All right, in this one we have log base 13 of x plus log base 13 of 12x minus 1 equals 1. Now, when you have two logs with the same base, you want to try to condense that into one logarithm uh, property here, one logarithm using the properties that we learned to condense. So since I have addition here, I can use the product rule of logarithms to combine or condense those two logarithms into one. So it gives me log base 13 of x times 12x minus 1 equals 1. And I'll go ahead and distribute that x to 12x and negative 1. So now, since I have log base 13 of 12x squared minus x equals 1, then I can now rewrite this in exponential form. So keep the base of 13 as the base, and then 12x squared minus x will go to the left, and 1 will become the exponent. Will go to the right, sorry about that. So now I have 13 to the first power equals 12x squared minus x. I see that this is a quadratic equation because I have x squared in there. So that tells me that I want all of my terms on the same side of the equal sign. So now I'm going to subtract 13 from both sides of the equal sign, both sides of the equation. And I need to factor this. So depending on which method you use for factoring trinomials, you want to factor this trinomial. I'm going to use the AC method. So I multiplied 12 uh, times 13, which is 156. I needed to find a pair of factors that equal negative 1, which would be negative 13 and positive 12. So I can rewrite this as 12x squared minus 13x plus 12x minus 13. So using the AC method, I split the negative 1x into negative 13x plus 12x. That would be the negative 1x there. I replaced it. All right, and made my two groups, and then I factor out the GCF out of each group. Factor out a 1 out of the second parentheses since I could not factor out anything else. So I end up with the factors of x plus 1 times 12x minus 13. Okay, so set each factor equal to 0. And solve each one of the equations. So in the first equation, I have x plus 1 equals 0. I need to subtract x from each, subtract 1 from each side. So x could be equal to negative 1, or let's solve the second equation here. Start off by adding 13 to each side, and then undoing 12 times x by dividing by 12. All right, now we have two answers. We need to look at our domain. So if I look at the first log base 13 of x, I know the domain for that is simply x is greater than 0. However, I had another logarithm that said the log base 13 of 12x minus 1, which must also be greater than 0, so I need to solve this. So add 1 to both sides, and then divide by 12. So x must be greater than 1/12, which means x must be positive So if I look at this x equals -1, that is not in my domain because it is not greater than 0 or it's not greater than 1/12. Um, the 13 over 12, which is equal to 1 and 1/12, that is in my domain, so that is a valid solution, and that is my exact answer. Okay, we're going to take a look at one more problem, one more example. So here we have the, looks kind of the same. We have log base 6 of x plus 31 minus log base 6 of x minus 4 equals 2. So you see I have those two separate logarithms, but they have the same base. So now I want to condense that into one single logarithm. And since I have subtraction, I will use the quotient rule. The quotient rule says that in reverse, if I'm subtracting two logarithms with the same base, then I can divide whatever I'm taking the logarithm, finding the logarithm of. So that would be log base 6 of x plus 31 over x minus 4. All right, I have it in a single logarithm. Now I want to rewrite my equation in exponential form. So I have log base 6. So I'll keep the 6 as my base, and the 2 comes over as the exponent, and the x plus 1 over x plus 31 over x minus 4 goes over to the right hand side. Okay, so we have 36 and I need to solve this equation for x. So I want to remove the x minus 4 out of my denominator, so I need to multiply both sides by x minus 4. That will cancel on the right hand side. So now I have 36 times x minus 4, and if I use my distributive property, that's 36x minus 144 equals x plus 31. Okay, so I'm going to make two moves at one time here. I'm going to subtract 1x from each side. And then I'm going to add 144 to each side. All right, and then the final step for solving for x would be to divide both sides by 35. Therefore, x equals 5. Before you put that in as your solution, you need to make sure that it is in your domain. So going back to my original problem, I need to look at my domain for each one of the logarithms and make sure that that 5 falls in my domain of the intersection of those logarithms. So x plus 31 must be greater than 0, so x must be greater than 0. And x minus 4 must be greater than 0, therefore x must be greater than, I'm sorry about that over here, y'all. That's negative 31, forgive me. X must be greater than 4. So the intersection would be greater than 4, which 5 is greater than 4. Therefore, 5 falls in my domain and is the solution of this equation. Alrighty, good people. I hope you found that video to be helpful. I'll see you on the next one. Thank you.